My name's Roger Moore. We're going to have a little talk about robotic exploration of Jupiter. Originally, I was going to do just something on Juno, which is NASA's current mission to Jupiter, but that started me thinking about these other spacecraft that have been there in the past, and so I thought I'd give a little history lesson before we'll eventually get to Juno. But and kind of in some ways this is a tribute to NASA. They've had some remarkable success with these robotic spacecraft. Can you see that slide okay? Can you see the screen all right with the lights on? Okay. So there's been 9 spacecraft have passed by or explored Jupiter. Some of these, it was just a planned flyby. That's all they were going to do. Some of the spacecraft were on their way to do something else. 2 of them, though, it was a dedicated mission to Jupiter. That's Galileo and Juno. So why do we spend so much time exploring Jupiter? Well, it's largely composed of hydrogen and helium, which are gases that may have been present when the solar system formed. Giant planets may have played an important role in the formation of the other planets, not only in how much material each planet acquired, but the planet's position from the sun. By measuring water and oxygen in Jupiter's atmosphere, we may better understand how these elements spread to the rest of the planets, especially to Earth. And Jupiter's moon, Europa, may have conditions that support life. So we'll start with the Pioneer missions. Pioneer 10 and 11. There were earlier Pioneer missions that were just interplanetary missions. Some of them were just proof of concept things. But Pioneer 10 and 11 were the first 2 to go out to the outer solar system. So Pioneer 10 was launched in March of '72. It arrived in December of '73. Excuse me. Pioneer 11 launched in April of '73, arrived December of '74. So each one took over a year and a half to get there. Each one of these spacecraft, well, they knew these spacecraft were going to continue on, so they wanted to put some kind of a memento on there as to where the spacecraft came from. So each one of them had a gold anodized plaque that was designed by Carl Sagan and Frank Drake to give whatever alien culture might encounter them some information about us. A question, Walker?
Oh, sorry. I was just going to say that Voyager 1 had one of those too.
We'll get there.
And
we'll
on
get.
it had instructions on how to build a phonograph so you could play the record.
Yeah, very good. Voyager 1, as he said, Voyager 1 had something similar. We'll get into that too, but thank you.
Yeah, and it was gold too.
So this is the Pioneer plaque. There's a lot of, so this was just attached to one of the antenna arms on the outside of the spacecraft. A lot of symbolism in here, some of which I don't quite understand. This represents a hydrogen atom, which hydrogen is the most abundant element in the universe, so they're thinking that anybody else would be able to recognize this. These lines radiate out from the sun, and they represent the relative distance to a certain type of star called a pulsar. So if you knew where each one of these pulsars were, you could figure out where the sun was. A drawing of humans, of course, and they drew them in front of a drawing of the spacecraft, so you'd have a relative idea of what our size was. And of course the solar system and which planet the spacecraft came from. There's a lot of funny things about deciding what human figures to put on here. At one point they were going to have them holding hands, and then they decided, nah, some alien culture might think it's all one creature then. No, seriously. Then they thought, well, we'll give them the high greeting, but you know, who knows what that might represent to somebody else. But mostly they wanted to show that we had opposable thumbs. So the Pioneers returned detailed images of Jupiter and the Great Red Spot, the best we had at the time. They charted the radiation belts and magnetic fields around Jupiter, made measurements of Jupiter's atmosphere, and they determined that Jupiter gives off more energy than it absorbs. Pioneer 10 was the first spacecraft to pass through the asteroid belt. The asteroid belt is a group of asteroids that orbits between Mars and Jupiter. And at the time, we had no idea if this was going to be successful or not. We could have entered the asteroid belt and just gotten smashed up, so they had no idea. So this was a big success. and it was the first to directly observe Jupiter. Then Pioneer 11 actually went on to study Saturn too. So this is one of the early images from Pioneer 10. That dark spot you see in the center is probably a shadow of one of the moons, or the moon itself in front of Jupiter's surface. And the great red spot on the left. And I think a slightly better image from Pioneer 11. Next up is the Voyager missions. So the Voyagers were both designed to fly past Jupiter and Saturn. They were launched in different months of 1977, and each flew past Jupiter in 1979. And as Walker said, they both had a gold-plated copper disc with information about the Earth. This was a disc that was just affixed to the outside of the spacecraft. So that's the golden record. The top one is the jacket the record was in, and notice it has some of the same symbolism as what was on the Pioneer plaque. The bottom one is the record itself, and this was an analog record, much like the vinyl records that people listen to music on, or used to, but some people still do. So they also included a cartridge to play the record and instructions on how to use the cartridge. How would you like that view out of the front of your spaceship? So this is Voyager 1, just a time-lapse images. Voyager 1 approaching Jupiter. What I really like about it is it shows the dynamics of the atmosphere. When you look at a picture of Jupiter or look at it through a telescope, it looks very static. It looks like a pretty painted planet, but it's very dynamic. And what I also really like is that these bands flow in opposite directions. You see some of them are going from left to right, some are going from right to left. It's crazy. So the Voyagers examined Jupiter's turbulent atmosphere. They imaged volcanoes on Jupiter's moon Io. Discovered a tenuous ring system around Jupiter. So this is the planet. This is the ring system. You only see part of it. Detected evidence of an ocean under Europa's crust. Europa is one of the moons. Since the primary mission was successful, they sent Voyager 2 on to look at Uranus and Neptune, and that's the only spacecraft that's visited those two planets. Next up is Galileo. Now, Galileo was dedicated to studying Jupiter. So it was launched in October of 1989, arrived in December of 1995. On the way, it visited two of the asteroids, Gaspra and Ida. That's both of them in that picture, but they weren't next to each other like that. They just took the two images and put them together in one so you could see them both at the same time. And one of these was about 60 kilometers long and one was about 20 kilometers. Galileo delivered a probe into Jupiter, and it descended about 97 miles. Measured Jupiter's upper atmosphere. It lasted about an hour before it succumbed to the temperature and pressure. Found higher wind speeds than they predicted and a slightly different chemical composition than they thought was going to be there. So Galileo studied Jupiter and the inner moons for almost 8 years. Found evidence that Europa has a saltwater ocean. Now it's not just water, it's saltwater beneath its crust. Studied volcanic activity on Io, discovered magnetic fields generated by a moon, by Ganymede. It's the only moon they know, at least so far, that has its own magnetic field. And these are some of the wonderful images of the Galilean moons, the 4 moons that Galileo studied, taken from the Galileo probe. Europa is the second one. That's the one they are pretty sure has a saltwater ocean beneath its crust. It was also present when comet Shoemaker-Levy 9 split apart and smashed into Jupiter. This was a big event, not only because, well, mostly because it shows that this stuff can still happen. And these are the impact sites. You see these glowing areas. That's where the pieces of the asteroid or the comet impacted the clouds of Jupiter. Next up is Ulysses. This was a new one to me. I had not heard of Ulysses before. Had anybody heard of Ulysses? Monty, you know about Ulysses?
Not me.
No, new one to me. Ulysses was a joint NASA-European Space Agency mission. And this mission, launched in October 1990, was to study the sun. But they wanted to study the sun from a polar orbit. That is, rather than orbiting like the planets do around the equator, they wanted it to orbit over the north and south poles of the sun. So it would take a tremendous amount of energy to get a spacecraft into that orbit. So what they did is they sent it out to Jupiter, launched it, sent it out to Jupiter, whipped it around Jupiter, and threw it outside the plane of the planets. So it ended up in an orbit like this. It was perpendicular to what the planets do. And then, so as long as it was going by Jupiter, it studied the radiation belts, the magnetic field, and then it gave us lots of information on the solar wind, solar particles, solar magnetic field. And then we have Cassini. Cassini, also a joint NASA-ESA mission. This one was to Saturn. Launched in October of '97, flew past Jupiter in December 2000, captured some wonderful images of Jupiter, and it studied Saturn for 13 years. So this is also a time lapse of Cassini approaching Jupiter. This is about 24 hours. They just took it in software and spread it out so you can see the whole surface. And once again, look at the turmoil in the cloud tops. I think this is just fascinating. New Horizons was the next. It was a mission to Pluto. Is a mission to Pluto. It was a mission past Pluto now. Launched in January 2006. Did a flyby and a gravity assist. That is, it took some of Jupiter's gravity to throw it into a faster speed out to Pluto in 2007. And it gave us new information on Jupiter's moons, its rings, its atmosphere, its magnetic fields. So these are images from New Horizons. This is a volcanic plume on Io. A new image of the rings, and notice that you can see now that there's two rings there. So where are they now? This is one thing that intrigued me about these earlier spacecraft, because there are first emissaries out into space. They're going on. They're not coming back. So Pioneer 10 is, so this is our solar system. Pluto would be right out here. And this is not to scale. But Pioneer 10 is heading off in one direction. Pioneer 11, just the opposite. Voyager 1 off this way. Voyager 2 off this way. New Horizons is just outside of Pluto. So signal was lost to Pioneer 10, which was launched in 72, in January of 2003, so 30 years later. They finally could not get a signal to it. This one, the power supply just dwindled. It was a radioisotope that decayed eventually beyond where it could provide enough power to run the radios. But it is it's going in the general direction of Aldebaran, which is the red giant star that we think of as the Eye of Taurus. And it will get there in about 2 million years. Signal was lost to Pioneer 11 in 1995, and it should pass the nearest star in Aquila in about 4 million years. Both the Voyager spacecraft are still functioning. They have shut down a lot of the instruments, but they can still communicate to both of them. Voyager 1 entered interstellar space in 2012, roughly, and Voyager 2 is not far behind. The Galileo spacecraft was sent plunging into Jupiter when its fuel ran out in December 2003 after orbiting roughly, I think it was 8 years. Ulysses, the one that ran around the sun, operated for over 18 years, and they finally shut down communication with that in 2009 as its orbit drifted farther from Earth. Cassini orbited Saturn for 13 years, and then it was sent plunging into Saturn just September of last year after these dramatic maneuvers between Saturn and Saturn's rings, and then it ended its mission. We had a nice talk on that last month by one of the engineers who was part of that program. New Horizons went past Pluto in July of 2015. It analyzed the atmosphere, the surface. It gave us some spectacular images, and it's heading out to another Kuiper Belt object in 2019. I think it'll be January of next year that it'll pass this other object. So getting back to Voyager for a minute, when they say it's in interstellar space, you know, the sun throws out a lot of radiation, and besides the light and the heat that we're accustomed to, it throws out a lot of charged particles, protons, electrons, alpha particles, and these expand out around the sun in a bubble that they call the heliosphere. So inside that bubble, radiation from the sun dominates. Outside the bubble, radiation, interstellar radiation dominates, radiation from other stars, gamma rays and the like. So if you're riding in a spacecraft and you're measuring the radiation, you get to this area where the direction and the type of radiation changes over time. And that's what Voyager 1 went through 5 years ago. So they consider it to be in interstellar space just because it's outside of the radiation influence of the sun. So present day, Juno, mission to Jupiter. It was launched in August of 2011, arrived in July of 2016. The mission of Juno is to study the atmosphere, the composition, magnetic fields, and just gain a better understanding of how Jupiter formed. In Greek and Roman mythology, Jupiter was the king of the Olympian gods. He was mischievous. Juno was Jupiter's wife, so when Jupiter wanted to create mischief for some other gods, he would throw up a veil of clouds around himself to hide what he was doing. And Juno could see through that cloud, that veil of clouds, and see what he was up to. So that's the purpose of Juno, is to see through Jupiter's clouds. So this is the path it took, kind of a typical path to get to the outer planets. You launch from Earth, maybe do one orbit around the sun, do a little bit of maneuvering here, come back, pass one of the planets, in this case it passed Earth again, grab a little gravity assist from Earth, and then continue on out to Jupiter. That's the spacecraft. I mostly put this image in here to show you the size of the spacecraft relative to a human. But the instruments on board, it had a microwave radiometer to study the atmosphere. It has a magnetometer and gravity science systems to study the inner structure by mapping gravity and magnetic fields. An ultraviolet and infrared imager to study the chemical composition of the atmosphere. A waves experiment to study electric fields and particles around Jupiter. And a Juno cam. The Juno cam is a digital camera primarily there for public outreach. They knew that most of the public would probably not be interested in the science, but they would be interested in the views and the images. So they included this camera. And there's a website you can go to, it's listed there, where you can download the images, you can discuss the images with other people, you can vote on where you'd like Juno to take more images. So it's just to keep the public involved, but it's also actually sent back some spectacular images. Most of the electronics in the spacecraft are enclosed in a titanium box just to protect them from the radiation around Jupiter. So this is Juno. You have to, when you have a spacecraft, you need to stabilize it in some way. You need to keep it from doing random spins and tumbles. And they'll often use something called reaction wheels, which are basically little flywheels that spin rapidly inside the spacecraft, and they stabilize it much like a spinning bicycle wheel stabilizes your bicycle. Well, reaction wheels are heavy, and they wanted to keep the weight down. So what they're doing with Juno is they're spinning the entire spacecraft to keep it stable. So it rotates anywhere between 1 and 5 revolutions per minute, depending on what they're doing. Notice it also has solar panels. It has enormous solar panels. They're about the size of a tractor trailer. No spacecraft that's gone this far from the sun has been able to use solar power in the past. They've all used some kind of a radioisotope power supply. Because the apparent size of the sun from Jupiter is only about 1/5 of the apparent size from the Earth. but solar panels have become more efficient, so they now can supply enough power for the spacecraft, even out at the distance of Jupiter. Also along for the ride are 3 Lego figures. Once again, public outreach, just to keep kids interested, just to let them know that scientists are not just a bunch of geeks, they can also have fun. And of course it's Lego company PR. But they're figures of Galileo, Juno, and Jupiter. Now these are not your typical Lego figures. These are made out of a special grade aluminum. They're wrapped in thermal blankets. They're carefully tucked away inside the spacecraft. And there's also a plaque given to us by the Italian Space Agency that's dedicated to Galileo. The plaque has a self-portrait, and then the text on here are some of his notes from when he was observing Jupiter's moons in the early 1600s. So Juno's on a very eccentric orbit. That is, it gets close to the planet, it gets far away. And they mostly do that so that to limit its exposure to these radiation belts. So they go quickly through the belts and then back out again. They're spiraling these orbits around the equator of the planet so that eventually they can cover the entire planet. So originally they were going to do several of these long orbits like they're in now. They're 53-day orbits. They were going to fire up the maneuvering rockets and bring Juno in much closer to the surface, into a 14-day orbit. But unfortunately they ran into problems with 2 of the valves on the maneuvering engines, and they just can't depend on those valves opening and closing at the right time. So rather than risk sending the spacecraft who knows where, they just decided to leave it in this longer orbit. But the downside to that is, if they could do the shorter orbits, they were planning on finishing the entire mission in about 1.5 years. Now they're going to have to extend it out to about 4.5 years to cover the entire planet. So some of the early findings, they've found that Jupiter is not uniform layers like they thought, and the structure gradually changes with depth. They're also thinking there is no solid core to Jupiter as they used to think it had. Jupiter's magnetic field is stronger and more uneven than they had predicted. There's significantly more ammonia in the atmosphere, suggesting maybe an ammonia-based weather system. Jupiter has some powerful auroras, and they have not quite yet figured out the source of these auroras. And there are cyclones on the poles. If you saw the presentation, or if you've studied what Cassini found around Saturn, Saturn had this big hexagonal shaped storm around on one of the poles. Jupiter has these chaotic cyclones on the poles. And another great image from the Juno camera, just a close-up of the swirling eddies in the cloud tops. And once again, understand that this is not static. This is a very dynamic, constantly changing image. Gave us a nice close-up of the Great Red Spot, which right now is measuring about 1.5 Earths wide and about 200 miles deep. Sent us back images from within the rings of Jupiter. So this is looking out from inside the rings. Notice right here is Orion's belt. So they're going to continue on to July 2018. Hopefully they'll get an extension and we'll be able to finish the entire mission in 4.5 years. Whatever happens at the end, they're going to plunge Juno into Jupiter, just like they did with the Galileo probe. And then I'll leave you with this. It's an image from Voyager 1 that Carl Sagan suggested when it was out past the orbit of Neptune. He said, let's turn it around, take a picture looking back towards Earth, which they did. And he had some very interesting things to say about these images. If you can't see it, it's right there. That's us. The stripes you see on the image are just artifacts. All right. Any questions? Thank you.